Hi guys, today we will be covering 10.3 arcs and chords. You guys will be able to recognize and use relationships between arcs, chords, and diameters. So we're starting out with a theorem here, theorem 10.2. This says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So this is saying if our two arcs are congruent, we know the chords have to be congruent. We know the opposite is true. If you know the chords are congruent, we know the arcs are congruent. So it works both ways. We're going to work on a proof now, proving this theorem. So we can't use the theorem because we are trying to prove it. We are given circle P. We are told that arc QR is congruent to arc ST. So we know this arc is congruent to this arc. We are trying to prove that segment QR is congruent to segment ST. And I know the difference. This means that we have an arc here. This means that we have a segment. So based on that little change, a little curve arc versus a straight segment makes all the difference. So obviously we always start out with our given, and then we notice some things that are happening in our image here. We notice that angle QPR is congruent to angle SPT. Now this is not by vertical angles theorem, guys, because they are not vertical angles. This is based on what we learned in 10.2. If arcs are congruent, their corresponding central angles are congruent. So we learned that if we have a central angle, the arcs have to be the same. Or if the arcs are the same, we know the central angle is the same. Once again, that one also works both ways. Step 3, we can say all of these segments are actually the same length. And we know that's true because they are all radii. And all radii of a circle are congruent. So we can say that QP is congruent to RP is congruent to TP is congruent to SP. They are all the same because they're all radii. So to write that concisely, all radii of a circle are congruent. That's just true. Now, I actually have enough information to prove these triangles congruent. The single red mark, guys, that's what I'm trying to prove. So I can't use this. This is what I am trying to prove true. I kind of don't like that they marked it since that's what we're trying to prove, but they did. Anyway, with the information I just added, I can prove these triangles congruent. So that triangle is congruent to this triangle. So I have triangle PQR is congruent to triangle PST. This is by side angle side, bringing back some of that older stuff. Now that our triangles are congruent, we are guaranteed that the thing we are trying to prove is true. We know that segment QR is congruent to segment ST because corresponding parts of congruent triangles are congruent. So we can now use this theorem whenever we want. Let's go ahead and look at example 1 and use it. So this tells us a circular piece of jade is hung from a chain by 2 wires around the stone. Guys, jade is just a type of stone. So we have segment JM is congruent to segment KL. These are both chords. Since they are congruent, we know these arcs have to be congruent. And this is arc measure, guys, not arc length. So we are trying to find the arc measure of JM, arc JM. And we know it has to be the exact same as arc KL. So it is simply 90 degrees. When you're ready, flip your page. Try that you try. Pause me so that way you can practice. Okay, so circle W has congruent chords RS and TV. Those are already marked. We are given that arc RS is 85. We are trying to find arc TV. You know that these have to be the same. We just did a proof about this. So arc TV is also 85. We can also do a similar thing given two circles if you know your circles are congruent to each other. Because we've learned when the circles are congruent, they have the same radii, they are the same. So this tells us that our two arcs are also congruent. So this arc is congruent to this arc. Sorry, my highlighting's not that great. Which means, by our theorem, we know the two chords have to be the same. So we can set up and solve for x. So we have 7x minus 2 equals 5x plus 6. We will subtract 5x on both sides and add 2 on both sides. So 2x is 8. So x is 4. Now, we're not done. I know I boxed it. It's asking us to find segment WX. So I need to plug this back in. So I take 7 times 4 minus 2, or 28 minus 2, which gives me 26 for my final answer. Make sure to read the whole problem. I almost missed that. You guys, pause me. Try that you try. Alrighty, let's do it. Same as last time. You are given two circles that are congruent, and you are given that your two chords are congruent to each other, which guarantees, from the theorem we just learned, that, I'm sorry, let me take it back. You're given that the two circles are congruent. You're given that the two arcs are congruent, which guarantees the chords are congruent. I think I said those backwards. Anyway, since the chords are congruent, we are going to go ahead and equal them to each other. And then we'll solve for x. So we get that x is 6. Once again, that's not what it's asking for, though. It's asking for segment LM. So we need to plug that back in here. So we have 2 times 6 plus 1. That's 12 plus 1, which is 13 for LM. Okay. So we have congruences. That's not too tricky. Let's go ahead and look at these next two theorems. So it says, if a line, segment, or ray divides an arc into two congruent arcs, then it bisects the arc. So this is kind of a new thing here. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. That means, since we have a diameter here, and it is perpendicular to this chord, we are guaranteed that these two segments have to be congruent to each other, and these two pieces of the arc must be congruent to each other. 10.4 tells us the perpendicular bisector of a chord is a diameter or radius of a circle. So we are guaranteed that if this is a perpendicular bisector here, we know for sure that this has to be a diameter or a radius. Oops, I ran out of space. Pretend that says radius. So we have example 3 here. We're going to use this fact. It tells us circle G, and we know that the measure of arc DEF is 150. We are trying to find DE. Because this is a radius that cuts the chord at 90, we are guaranteed that these two arc segments are congruent. So to solve, all we have to do is take the total divided by 2, and that will find each half. So the measure of arc DE is 75. Okay, each of these work together to get the total of 150. Pause me again, try the U try. All right, so this one tells us circle Z. We have the measure of arc WUX is 160. We are just trying to find UX, which is this part. Once again, we have a radius that crosses that chord at 90, which guarantees that these two pieces are congruent to each other. So all I have to do is 160 divided by 2, which gives me 80 for the measure of arc UX. Now, side note, we're also guaranteed that these chord segments are congruent to each other. I know it doesn't ask that, but I just wanted to point out that that would be 7. On the next page, we have example 4. It says, in the ceramic stepping stone below, diameter AB is 18 inches long, and chord EF is 8 inches long. Find CD. This problem can be a little bit tricky. You will have a bonus on your test, very similar. Now guys, notice this picture and this are exactly the same. I'm going to work with the one on the right side just because there's less going on. But I wanted to show you like as part of the stepping stone, the like more real life version. Anyway, I'm going to work over here because it's a little bit easy to see what's going on. So it tells me my diameter is 18. So I marked it. That's why I highlighted that in blue. It's a little hard to tell. I also know that my chord EF is 8 inches long. Okay, we are trying to find CD here. I promise you this is actually really not that tricky. You do have to think a bit though. Let's first of all find the radius. Remember, radius is half of your diameter. So we get 9 here. And I'm going to actually draw in a completely new segment. I'm going to draw in a radius because remember, all radii are the same. So I can put a radius anywhere. I'm picking specifically from point C to point E. That radius I know is 9 inches because all the radius are 9 inches. I also learned, since this is 90 here in my last theorem, that these two parts have to be congruent to each other. And since that chord is 8, if I divide that by 2, that gives me that this segment is 4. Maybe some of you will see where I'm going with this. I now notice that I have a right triangle here that I can do Pythagorean theorem for to find the segment CD, which is what the question is asking for. So I redrew my little triangle. I'm going to call this x. It is a leg length, so I'm going to take x squared plus 4 squared equals 9 squared, because remember, your last thing is always the number across from the 90. So I have x squared plus 16 equals 81. We subtract 16 on both sides. X squared is 65. take the square root. Depending on what the question asks, you could either leave it like this, or you can write it as a decimal if you would like. Square root of 65 is 8.06. Now these are both C, D. They're the exact same answer. You can write it either way. I'm just going to write it the decimal way. Okay, so yes, you did have to like come up with a lot of your own numbers and even draw in your own segment, but the math itself is not that difficult. Like I said, there is a bonus question like this on your test. So with that in mind, go ahead and pause me. Try that you try. Okay, similar idea. This time we have a circle. Once again, we are given our diameter is 14. Our chord, RT, is 10. We are trying to find UV again. So, same idea. I'm going to take the diameter and I'm going to find the radius. To find the radius, I take the diameter and I divide it by 2. Once again, I'm going to draw in a right triangle here. Since all radii are the same, I know that radii has to be 7 inches, technically. I should have put inches up here as well. Then I also know, based on the fact that this is 90, that these two parts are congruent, making this section 5. Because the whole thing is 10, half of it is 5. So I can draw myself a right triangle. My hypotenuse is 7, one leg is 5. I am trying to find VU, which I'm going to call X. Same idea, do Pythagorean theorem. We have x squared plus 5 squared is 7 squared. So x squared plus 25 is 49. Subtract 25 on both sides. So x squared is 24. Now, this time, if it asks to leave it as a reduced radical, you can actually reduce this one. So this would reduce to 2 square root 6 inches. If it doesn't ask for a reduced radical, you can just plug this into your calculator, and the square root of 24 is 4.90 inches. So those are your options for your answers. It really just depends on what the question asks for. This one doesn't specify, so I would take either. Go ahead. I would mark that there's a bonus question on the test, like this one, just so you remember. And that way you can study it. Okay, we've got another theorem. We've got theorem 10.5. It says, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So now we are looking at this segment that is attaching these chords. Notice that segment specifically has to touch the chord at 90. Remember, our shortest distance to a line from a point is at the perpendicular. So, this is saying that if these segments are congruent, we know our chords are congruent, and vice versa. If our chords are congruent, we know those segments have to be congruent. So we're going to do some math here. Looks like it didn't go away the last time. Okay, so this first question, there's actually a tiny typo here, guys. Add that this should say GH is equal to EF is equal to 24. Fix that, okay? We are finding segment PG. Nope, sorry, PQ. That's this segment here. So we're going to have to plug it back in. Now, The fact that G, H, and E, F equal 24 is not something that's really super necessary. We only really need to know that E, F equals G, H. Because these chords are congruent to each other, we are guaranteed that these segments that are connecting them from the center to the chord are also congruent. So all I have to do is set these equal to each other. And notice, guys, it's a little hard to tell where the 4x minus 3 goes. That's why I drew this arrow. It belongs with this connecting segment. That way we can set these equal to each other. So I'll add 3 on both sides. I'll subtract 2x on both sides. This gives me 2x is 6. So x is 3. That's not my final answer, though. I'm trying to find PQ. So I plug it back into PQ. So I take 4 times 3 minus 3, or 12 minus 3, which is 9 for PQ. Now PQ is the same as PR. You could have solved for either, you would get the same answer. Okay, go ahead and pause me again. Okay, so like the last one, this one tells us that our chords are equal to each other. They both say they equal 29, but that's not helpful, okay? We are just using the fact that they are equal here to know that these segments from center to chord are congruent. So I'm going to set these equal to each other. 3x minus 6 equals x plus 8. Add 6 on both sides, subtract x on both sides. We get 2x is equal to 14. So x is 7. Once again, not my whole answer. It wants RS, so I gotta plug this back in. 7 plus 8 is 15. That is the length of RS. Now, hopefully you realize I put a little star here. There is a question similar to this on your test. It's not exactly the same, but it is similar. It does solve the same, okay? Now, the one on your test only asks you to solve for x. You won't have to plug it back in. Also, I skipped it, but up here on example 2, there is a question similar to this as well. Once again, it's not exactly the same, but it solves the same. Although, once again, the question on your test only asks you to solve for x, not to plug it back in. So, those are maybe ones that I would star, along with this being a bonus type question, so that way you can have a heads up on what you can start studying for your test over these sections. If these notes finish early, you can work on the next worksheet in your packet or the previous delta. Just use your time wisely. Have a great day, guys.